Hello, this is just a video showing my Kerry AG lathe. Basically, I'm having an issue with the clutch setup where I can't adjust it to function correctly. It either engages, but then when it's disengaged it drags, or it engages and it slips and then it will release. So I've read online that this is a pretty common issue with these older Kerry AG lathes. Some people I've read have managed to fix it by relining the cone clutch. And I've actually got a piece of leather that I did think about lining this, but I just wanted to check everything else through before. I also read that someone had lined the inside of the pulley with Tufnol. On the lathes.co.uk website, it mentions that there were replaceable Tufnol inserts back when these were being made. Mine doesn't show any evidence of there ever being. There's no remnants of a friction disc being there, but maybe that got taken out a long time ago. Anyway, in this video I'm just going to show how it all comes apart and show all the components. Maybe that will be useful to someone in the future, but really I'm just hoping that someone watching it might be able to give me some advice on on what's kind of wrong with this one. If you've ever had one apart before, you might notice something a bit different from mine to yours. Anyway, the video is going to be pretty long, but yeah, thanks very much, and hopefully I'll make another video where it's fixed. So yeah, cheers. So I'm just checking how much throw the cam has onto the plunger. I'll zero that there and then operate the cam. About 69 thou, which is 1.76 millimeters. So I just did a quick drawing of the setup. So basically all of the throw, this 1.6 millimeters, is governed by the cam lobe. So in the brake position, this cam lobe sits up here and the spring pushes the cone away from the pulley and onto the brake. And when you're in engage mode or drive, then the cam pushes the plunger and the cone is then forced into the pulley. All the adjustments done off the nut. So you basically tighten this nut up and it pulls the pulley onto the cone. I've just shown here a friction disc which isn't present on mine, but this is what I'm thinking of installing. But I'm just wondering on other people's machines, how much throw do they have? Because I don't have all that much. 1.6 millimeters, which is non-adjustable, that's set from here. So yeah, I'm just wondering, if I go and make new friction material, get it lined by a company or whatever, am I still going to have the problem because I've only got 1.6 mils of travel? Yeah, there you go. So here's the input shaft. This keyway is what the pulley slides on, and this slot is for the dowel to sit in, and that dowel is connected to the cone clutch. and basically the plunger presses against the dowel and actuates the cone clutch in and out. As you can see on mine, there's a small amount of wear here, but that's worse on the other side where it's a bit more worn just down here. So I might try and smooth this out a bit to try and make the actuation a bit smoother and make sure it doesn't catch on there. Just to give a quick overview of the components, you've got the drawing here. So here's the cam, and that cam is actuated by this selector arm, and that is operated like this, which slides on the input shaft and operates this cam. That cam then operates this plunger. This plunger presses against this dowel, which operates, or which pushes the cone clutch and the brake. The clutch to the drive pulley is this side and the brake is this side. It actuates that in and out. There's then the outer plunger and the spring, and this helps push the clutch and the brake back into its braked position. And just to look at the condition of these parts, so the selector arm, it's got a bit of wear on the faces there, and a measurement would be on a thickest part, so a part that hasn't worn at all, about 246 thou, and then a part that is worn, we 0 and 246, and then a part that's worn, so it's worn about 13 thou, and that's across both sides. And then the plunger does have a small amount of wear on the end, but it's not terrible. The other end looks pretty good. The length of that is 1.746 inches. And then the dowel, let's get it focused. There is some of it's where I've taken it in and out a few times, but the actual contact area seems to be in pretty good condition. The second dowel does have a little bit of, I guess, galling, you would call that. And the length is 1.768 inches. And then the spring, and this is basically the part that holds the spring in. Then you've got the kind of cone assembly itself. It looks like someone has ground around this surface, and I guess what was happening is maybe at one point this bottomed out into the pulley, so they ground a bit of a chamfer onto there, and it looks like the same on this side. See, it's got a bit of wear on it. And inside the pulley, there's no deep grooves or anything, but it's hard to know what this looked like from new. And did this have some kind of, friction material bonded to it? I don't know. I don't know how much it's worn. So I just thought I'd show how the braking system works. So when the clutch and the brake cone is in its brake position, this face should make contact with this face, but mine's so worn, or the friction material is not there. I'm not sure if it ever had friction material, but mine never actually gets back to the braking surface. So, yeah. This is how the pulley and the cone sit together. I'm just going to put it all together so I can measure and see how much play there is on the cone clutch. And then I can work out what thickness of friction material, if any, I can fit in there. So, first bit that goes on is the selector arm. Like that. And next is the kind of linkage and the handle. So it's a little bit dodgy, but put that on as one piece. Like that. And you can rotate that. You can line that up. Easier said than done. Like that. I'm going to see that there. And the next bit to go in is a little pin. Like that. Just so everyone knows, this lathe is completely electrically isolated, of course. Okay, So now when you actuate, that's operating the cam. Let's nip that up. Okay. And then from this side, first you've got the plunger. And that has to go all the way in. Then the cone. You have to line that up with the slot. Okay, that's seated. So just checking this with the mechanism all in place. So that's fully in the brake position. Yeah, I've got 66 thou of movement. The next part that goes in is the next plunger. And then the spring. And then the spring retainer. And then the key needs to go in. And then the pulley. And then finally the adjusting nut goes on. And then the belt. So the procedure in the manual for adjusting the clutch, it tells you to unscrew the adjusting ring, which I've done. And it says move the clutch and brake lever in both directions, noting the full extent of the movement. So you can kind of see here. It then says place the clutch and brake lever to the drive position. Just fully to the right, so that's in the drive position. It says unscrew the adjusting ring in until pulley meets the clutch and brake disc. That's there. It says release the handle to the brake position. And then advance the adjusting ring until the next tapped hole aligns with the hole in the adjusting ring. So that'll be there. So now it's all adjusted. You can see that when it's not running, the pulley can spin when the brake's engaged. When you engage it, it seemingly is working. So we'll try and run it. Okay, so I've got the lid on just loosely. Power's on. So I can... And you can already see that it's dragging. So I'll put it in gear. But you can see how much it's dragging. I've just been doing a little bit of troubleshooting. So there's no spring in at the moment. I'm just using a screwdriver to act as that. So it's engaged there. So when I go to brake, it really takes quite a bit of effort to get that to go back. So I'm wondering if it's that wear in the slot that's causing that pin to get held up, you know, and making everything quite tight because it's binding really. So I'm going to take it back apart and see if I can clean that slot up a bit. Yeah, because that spring really is having to work hard to get that to go back. So I'm going to take it back apart.